Hello everyone. Welcome back to a series of live discussion. Let me once again welcome Mr. Ashwini Kumar Sinha and Mr. Suresh Dwivedi ji. Today we will discuss PMIC, that is Power Management Integrated Circuits that are used for wearable and DIY electronics. So my first question is, what is a PMIC and why it is important in circuits?
So basically, as we all know, the power management PMIC is stands for the Power Management Integrated Circuit. So if you design any kind of electronics and any kind of system based on batteries or DC power, then you need various kinds of systems so that the whole electronic circuit will able to get the required power in the regulated form. So generally we use a voltage regulator, and then if the system also need the battery, then we have the BMS module and different modules. So basically, power management integrated circuit stands for the everything, all of these things that is packed inside of one chip. So basically, if you use a different module for the suppose that for the voltage regulation, then a different module to converting the voltage down to up, and then another module for controlling the battery charging issue and other things, and another module for stability and of the power and other things. So all those different modules you need when you used different modules in the design, then it's also rises the cost of BOM, and it's also when you add a lots of module, then it also add the more failure points. So power management IC is one integrated IC have all these function inside itself, so it helps you in regulating the power inside the system. It ensures that the whole circuits get the power in regulated form. If the power is low, it will do little bit it will regulate the power around the range that is needed by the circuit, and it's control the whole power of the system, and that's why we call it power management integrated circuits. All the circuits are integrated inside one chip to manage the power of electronics.
Okay. So what devices commonly use PMIC?
The devices, like suppose that you have a smartwatch, or you have Bluetooth earphone, earbuds, or wearable device, or any kind of IoT device or automotive electronics, the consumer electronics, smartphone and tablets, all of them use the power management IC. So basically, in all those devices, we have one IC that manage the power, that manage the when the battery is low, it will manage it will regulate the power accordingly. When the battery is fully charged, it will regulate the power accordingly. When there is more power, then it will regulate the power and give that sufficient power that is needed by the circuit. If there is low power, then it will again regulate the power and give the sufficient. So it basically manage the whole power of the circuit that is needed by the device. So most of the devices need this IC, that is the PMIC, so that they can able to work without worrying about the regulating the power or optimizing the power or optimizing the efficiency. The PMIC do all these things by itself.
Okay, so what are the common components of PMIC?
So basically, the PMIC, the work of the PMIC is the regulation of the voltage, management of the battery, or sequencing the power system, monitors the power inside the circuit, current, voltage usage by the circuits, and protecting the circuits from over voltage, under voltage, thermal throttling, or the short circuit, over current, under current, over voltage, under voltage, and the clock management. So according to this function, the power management IC PMIC have these components, like the power management IC have the voltage regulator. They might also have the battery management system. They also have the power sequencing system. They also have the power switches. They also have the power monitors. They also have the protection circuits integrated inside. They also have the clock management system. So these are the components that is all these components are included inside one small package, one a small integrated circuit to manage all these things and gives you all those functions inside one IC. So voltage regulation, battery management system, power sequencing, power switch, and power monitors, protection circuits, all these are the components of the power management IC.
Okay, so we have a question from Yashaswini. How are PMICs and BMS different?
Yeah. BMS is battery management system. So they actually manage the battery, the charge and discharge of the battery. So they don't manage the power. Their work is, BMS work is only to manage the battery. Suppose that you have a BMS circuit in the EV. So what is function is to check the charge level of each cell inside the EV battery, and find out which cell is discharged more, and try to manage the battery charge of each cell, and try to maintain the charge level of each battery around the range that is required by the EV. So battery management system, BMS, is only for the managing the battery, but PMIC is little bit broader than that. PMIC is power management system. So it's actually manage the power. It is not only managing the charging and discharging of the battery, but it will also regulating the power. It is also protecting the circuit from over voltage. It also protecting the circuit from under voltage. It also protecting the circuit from short circuit. So suppose that you have a short circuit, then power management automatically cut up the switch and protects rest of the circuit. So if you don't have the power management IC, and you just use the voltage regulator and do some kind of short circuit inside the circuit, then whole other components might get burned out. But you have the power management IC, and it have the current sensor inside, integrated inside the chip. Then the chip when you do the short circuit, the chip automatically detects there is over current usage by the circuit, and there might be the short circuit. So it automatically turn off the power and protects your all the important component in the circuit. And so in this way, this power management, one single power management IC also helps you in protecting all the circuit with over voltage, under voltage protection. So power management IC, the main difference of the power management IC and the BMS is only dedicated for charging and discharging and monitoring the battery. It's the battery management system. But PMIC is the power management IC, and battery management system might be the part of PMIC. Most of the PMICs have, some of the PMICs for the IoT and wherever, have this battery management system inside it. So PMIC can have the BMS as well. So I think you understand what I want to say, and I think you got a broader idea and your doubt is cleared. What's the difference between battery management and PMIC? The one clear difference is, BMS, battery management system, is only for the battery, that manage the battery charging and discharging. PMIC is the power management system that actually manage the power, and BMS might be the part of the power management IC.
Okay, that was nice explanation. So, what happens if you remove the PMIC from a circuit?
Yeah. So if you remove the PMIC from the circuit, then might, like I've already told you, suppose that you have the over voltage things, and certain voltage fluctuation and under voltage thing, then your circuit might be damaged. Your important component might be burned out because of over voltage inside the circuits. Then the whole component get burned out. Whole circuit become unusable because of the short circuit. All of them components get burned out. But if you have the power management IC, then it actually regulates, it actually sense the over usage of the current, and automatically shut down the power of the whole system to protect the all the important components on the circuit. So if you remove the power management IC, then there might be instability in the voltage that is needed by the circuit. There might be the increase in the power consumption over the whole devices, and it affect the efficiency of the devices, the battery life as well, and it might also be damage the circuit on overheating and other things. And it also loses the loses the control over the power required by the circuit, each and every other component. You have to maintain the power, because in a suppose that you have a cell phone, and the camera needs certain amount of power, the display needs certain amount of power, and other things need certain amount of power. So if you have the power management, I think it will be able to distribute the power according to the need of those components accordingly. and the different level. But if you remove this, then you have to add a certain different power source, or you have to design the circuit to drop out the voltage for the certain level for each different component. So the overall bill of material and the overall efficiency of the circuit also decreased if you remove the power management IC from the circuit. So there are lots of factors that that affect the circuit and overall device working if you remove the power management IC. And if you power efficiency is one of the major factor of that, and protection of the circuit.
So, how do PMICs manage battery charging and discharging?
PMICs manage battery charging and discharging through a combination of hardware and the firmware designed to ensure safe, efficient, and effective power management, such as for battery charging management, it includes charging algorithm. Charging algorithm means constant current phase. The battery charged with a constant current until it reaches a specific voltage. On the other hand, constant voltage phase. Once the battery reaches the target voltage, the current gradually decreases while the voltage remains constant until the battery is fully charged. Another is charge termination. The PMIC monitors the charging current and terminates the charging process when the current drops below the certain threshold, indicating a full charge. Another is pre-charging. For deeply discharged batteries, the PMICs provides a low pre-charge current to bring the battery voltage up to a safe level before starting the standard charging. This is the very important. Pre-charging means when battery is deeply discharged, then initially it starts charging with slow current. Slightly it comes with a standard current. And another is a trickle charging. It also controls if the battery voltage is extremely very low. The IC may use a trickle charge to gently bring the voltage up to a safer level before switching to the regular charging phase. Another is battery health monitor, such as temperature monitoring. It also controls the battery temperature. It prevents as charging if the battery is too hot or too cold, when which can damage the battery or reduce the lifespan. Another is voltage and current monitoring. It is also very important. It continuous monitoring ensures that battery is charged within the safe voltage and current limits. Another is protection features. Protection features, it also controls PMIC also controls over voltage protection, OVP. It prevents battery from the being charged above the maximum voltage. Another is over current protection, OCP, means it prevents excessive charging current that could damage the battery. Another is short circuit protection. It stops the charging if there is short in the circuit. And that this IC also controls the discharge management, battery discharge management. First one is a regulated output. It provides a regulated output. The PMICs provide a stable voltage to the device component by regulating the output from a battery, ensuring consistent performance regardless of the battery's charge level. Another is power path management. PMICs manage the distribution of power from the battery to various components, optimizing efficiency and ensuring critical components receive power first. Load monitoring. It, it also monitors the device power consumption and adjusts the power delivery according to the optimized battery life. Discharge production. It also provide a battery from discharging below the critical voltage, which can cause permanent damage. Another is current limiting. It also ensures that the discharge current does not exceed safe limit to protect the battery and device components. Another is battery state of charge associated estimation. PMIC estimates the remaining battery capacity and provides this information to the device, enabling feature like battery level indicator and low battery warning, and also manage thermal management. Monitors PMIC monitors battery temperature during discharge and can reduce load or shut down the device if the battery temperature exceeds the safe limits. That's all.
Okay, so how does a PMIC handle power under different operational modes like active, idle, sleep mode?
So, like I have already told you, power management actually not only regulates the power, but it also helps you in optimizing and overall efficiency of the battery life and the device power consumption and overall efficiency of the whole device. So this how this will happen. So most of the power management IC have different kinds of modes, like active mode, ideal mode, and then the sleep mode. So what happens, suppose that if a device have a CPU or GPU, whatever the things is on the device for the processing. So if that GPU and CPU uses it at the highest level, the everything is processing and all the components need to work at its highest efficiency, then PMIC use its active mode to provide sufficient amount of power and energy consumption and optimize the whole amount of energy that is used by the chip, and try to regulate the voltage so that there should not be the you know the there should not be the processing there should not be the effect of processing on the processor on the main chip. And it also manages the thermal of you also do the thermal management of the whole circuit and monitors the temperature and current or required by the whole circuit and provide according to that. And in the active mode, it also use the dynamic voltage frequency scaling, DVFS. So what it will do, it will actually adjust the voltage and the frequency of based on the processor workload and optimize the overall power performance and efficiency. So suppose that if you use only voltage regulator, not use the power management IC, so voltage regulator will only do the regulation on under the certain range and continuously provide the regulated power to the system. But if you use the PMIC, then it have the different modes, and it will do provide the power based on the energy consumption needed by the processor. So in the active mode, it regulates the power. It will deliver the high amount of power that is needed by the CPU, and it will try to ensure everything is under control, the current, the thermal, and everything is under control. But there is another mode, that is the ideal mode. So in ideal mode, it is not actually it is not actually working in the full efficiency. Suppose that you have a chip, but you have a watch, and in after a few time your watch go into the sleep mode. So in the sleep mode, the energy consumption by the processor by the processor on the watch is not high, and it's only need few microamps to just to calculate the amount of time, and that's all. It's not needed much amount of the time. So so that in such case, the power management might go into the ideal mode. So it is not actually in active mode. It's not actually providing providing the power at the full effort, but it is in ideal mode. But it is in ideal mode. In the ideal mode, it is actually ready to quickly resume the activity. So suppose that whenever you tap the watch, then the power management actively suddenly and start giving the whole amount of power that is needed by the CPU. So it's reduce the power delivery in the ideal mode. It reduce the power delivery, it reduce the clock getting it reduce the it reduce the maintenance of essential function. And then the another mode is the sleep mode. In sleep mode, suppose that you're watching in the sleep, then for the long time, for the day or 2 day, after 2 day, it have to wake and give you the health data and something, do the calculation and other things. So in the sleep mode, it will deliver the minimum power that is required by the system. And it's deep down the power, and it have a backup management system. So whenever you need the whenever the CPU again needs the large amount of power, it will back up and start delivering the power and start doing the regulation according to the need by the whole circuit. And then another thing is battery conservation. So in the sleep mode, it start to conserve the battery so that the device will run longer in the long term use. So these are the different modes that will power management IC might give you: the active mode, ideal mode, and sleep mode. And on the different mode, it will transfer and give the power on the different levels.
Okay, so what factors should you consider when selecting a PMIC for managing varying loads?
When selecting power management ICs, it is very important to consider following factors such as the load current range. When you are designing a circuit, you have very clear which range of the load current you need. Means PMIC ensures that it can handle the maximum and minimum current of your application. Second is efficiency. It also monitor the high efficiency across the entire load range to minimize power loss and heat generation. So its efficiency can increase. Another is input voltage range. It is very important to consider the input load voltage range. Verify that the PMICs can operate within your system's input specification. Similarly, its output voltage accuracy should also very important. It checks the accuracy of the output voltage regulation, as precise voltage control is crucial for many applications. Another is dynamic load response. PMICs also controls the ability to respond quickly to charge the load current, ensuring stable operation under the verifying load. Another is thermal management. Consider the PMIC's thermal performance and whenever it includes features like thermal shutdown or thermal regulation. Another is a quiescent current. Low quiescent current is a important for the battery operated device to extremely battery life when the load is low or idle. Another is a protection feature. It ensures the PMIC has necessary protection mechanism, overcurrent protection, over voltage protection, short circuit protection, thermal shutdown. Scalability and flexibility. It choose that the scalability for future upgrade and modification in your system. It is also very important. Another is which type and package you are using. It is also very important. It makes sure that the PMIC package is suitable for your PCB layout and the space constraint. Suppose you are using a very deep package, then it will take more space. When you are using a SMD component, so it will take less space during the PCB designing. So package and type is very important. Another is control and interface option. Check It checks the control interface and programmability if your application requires dynamic adjustment or monitoring. Another is a power sequencing. PMICs also control the power sequencing system, build multiple power rails, ensure the IC supports proper power up and power down sequencing. Another is EMI performance. It is also ensures the electromagnetic interference EMI performance to ensure it meets your system requirement. Another is when you are designing the cost and availability of the PMICs is also very important. When you are designing, then you have to consider what is the cost and is it easily available. It, this parameter should also be considered. Another is vendor support and documentation. Good technical support and comprehensive documentation, data sheet, application notes can be invaluable for design and troubleshooting. When you do not have any data sheet, then it may create a problem when you are designing. You cannot read the maximum current, the minimum current, and what is the available capability, such as. So these things should be clear. That's all.
Okay, so how do PMICs ensure power efficiency to maximize battery life?
How bad? Just a minute. For ensuring the managed battery life, it is very important to use the where your application is very important for maximum battery life through the power efficiency is a very crucial function for these PMICs, power management integrated circuit, especially following parameters such as dynamic voltage scaling very important. Dynamic voltage storing consists of two parts. One is adjustable voltage level. The PMICs can adjust the voltage supply to the processor and other components based on their current performance requirement. By lowering the voltage during less demanding tasks, power consumption is reduced. Another is adaptive regulation. The PMIC dynamically adjusts the voltage rails according to the operating condition of efficiency for different load scenario. This is the dynamic voltage scaling. Another is dynamic frequency scaling. DFS. Frequency adjustment. The PMICs can reduce the clock frequency of the processor and other components when the full performance is not needed. Lower frequency results in reduced power consumption. And this in this DFS, another part is performance states. Implementing multiple performance states allows the system to balance performance and power consumption dynamically. Another is power gating. Power gating is also very important factor for maximum battery life. In this, you have to select the selective shutdown. The PMRC can turn off power to specific components or the sections of the device when they are not in use. They reduce power consumption by preventing idle components from the drawing current. Another is sleep mode, as explained by the AKS. The PMIC supports various low power modes such as sleep, deep sleep, or standby, where non-essential functions are powered down while maintaining core functionalities. And Efficient voltage regulation is also very important. Switching. In this, efficient voltage regulation has also two parts. One is switching regulator, another is low dropout regulators. In switching regulator, using buck boost or buck boost converters are used instead of linear regulation, significantly improve the efficiency, especially in the scenario of the large difference between input and output voltage. Another is low low dropout power. For applications which noise sensitivity is critical, LDO are used. LDO means low dropout regulators are used. Their low noise characteristics while maintaining efficiency with the acceptable range. Another is load balancing. It is also very important. Load current sharing in this system with multiple power rails or batteries, the PMIC can uh, balance the load across the different sources, optimizing the overall efficiency and prolonging battery life. Energy harvesting. PMICs in the energy harvesting system can manage the distribution and the storage of the harvested energy, supplementing battery power and improving the efficiency. Another is adaptive power management. In this, pro-reactive algorithm is used. In this, PMIC can use predictive algorithm to anticipate power requirements and adjust setting proactively. This can include predictive shutdowns or frequency scaling based on the usage of pattern. Another is real-time monitoring. In this, continuous monitoring of the power consumption allows the PMICs to make real-time adjustment to optimize the efficiency. Another is thermal management. In this, heat depreciation and temperature aware scaling. Another is battery health management. In this, state of charge monitoring, accurate monitoring of the battery state of the charge help the PMIC manage power draw and charging cycle more efficiently. Another is battery aging compensation. The PMIC can adjust charging and discharging parameters based on the battery's age and condition, ensuring optimized performance and the long life. Another is the PMICs with the low quiescent current, which is the especially important in the low power or idle state. That's all.
Okay, so what type of batteries will be used and what are its charging requirements? Okay, I think there is some network issue at Ashwini's side. So let me move on to another question. What safety features should be integrated into PMIC to protect the device and its battery?
Okay. To protect both the devices and its battery, PMIC's power management integrated circuits incorporate a range of safety features. Their features ensure safe operation under various conditions, prevent damage to the battery and device components, and enhance overall reliability and long life of the system. Few are the very important factors. One is over voltage protection. These ICs worked on the overvolt protection (OVP) functions, prevents battery and device components from the being exposed to voltage higher than their rated maximum. Mechanism: the PMIC shuts down the power supply or adjusts the voltage to a safe level if an over voltage condition is detected. Another is overcurrent protection. Another is overcurrent protection (OCP). It functions, it protects battery and device components from the excessive current which can cause overheating and damage. PMIC limits the current flow or shut down the power supply when an overcurrent condition is detected. Another is short circuit protection (SCP). It prevents damage caused by the short circuit, which can result in high current flow and potential overheating or fire. So, PMIC detects a short circuit protection and quickly disconnect the power supply to prevent damage. Another is over over temperature protection (OTP) function. It protects the battery and PMIC from the overheating, which can degrade performance and cause permanent damage. So, PMICs monitor the temperature and reduces the power delivery or shut down the temperature exceeds a safe threshold. Another is under voltage lockdown (UVL). Under voltage lockdown, in this case, it ensures the device does not operate within the insufficient voltage. So voltage is less and working voltage is high, then it also voltage insufficient. In this case, it causes the erratic behavior or damage to the battery and components. So, PMIC monitors the input voltage and prevent operations if the voltage falls below a certain level. And another one is a battery overcharge protection. It prevents the battery from the being charged beyond its maximum capacity, which can cause overheating, swelling, or explosion. So, PMIC stops the charging process when the battery reaches its maximum safe charging level. Another is battery over discharging protection to prevent the battery from being discharged too deeply, which can reduce the lifespan of the battery. So, PMIC disconnects the load or reduce power consumption when the battery voltage drops below the safe level. Another is call balancing for multiple cell batteries. Suppose there are multiple batteries are used, then it ensures all the cells in the multiple cell battery pack are the charged and discharged every, preventing imbalance that can reduce battery's life and safety. So PMIC actively manage the charge and discharge cycle of the each cell to maintain balance. Another is reverse polarity protection to ensure it prevents damage if the battery or power supply is connected with the reverse polarity. So, PMIC detects a reverse polarity and prevents power flow protection the device and battery. Another is fault detection and reporting to provide diagnostic alert for the various fault conditions, helping in the early detection and prevention of the potential issues. So, PMIC monitors various parameters and can signal fault to the host processor or dedicated monitoring system. And another is in-rush current limiting prevents excessive current draw when the device is initially powered on. Few devices, few applications, when you power on, they takes more current. In that case, which can stress the battery and components. So the PMICs ensures the initial power up current and ensures it remains within the safe limits. These are the few factors, and few more are thermal regulation and throttling. To the power, it manages the power output based on the temperature condition to prevent overheating. So PMIC reduces power delivery or implement throttling mechanism when high temperature are detected. Another is ESD, electrostatic discharge protection. It protects the device and PMIC from the electrostatic discharge, even that can cause immediate or latent damage. So PMIC includes ESD protection circuit to its safety and dissipate electricity charges. And another is a watchdog timer. Ensures the system remains operational and can recover from the software or hardware malfunctioning. So, PMIC includes a watchdog timer that can reset the system if it detects that the system is not responding correctly. So after including these safety features, the PMIC ensures that the safe operation of the battery power device protect the battery from the damage and the enhance the overall reliability and safety of the system. That's all.
Okay. So, what are the challenges in designing PMICs for wearable devices?
Yeah, so there are various challenges when you use the power management as in the wearable devices or miniature electronics or something like the earbud or the your AirPods or the wearable watch or some wearable sensors. So actually those earbuds or your AirPods or your smartwatch are very small size, and most of the the space is consumed by the battery and the main circuit. So you have very small amount of space available on the whole circuit for these power regulating and power management system. So PMIC is one of the best option to using in those, because if you use the voltage regulator and if you use the battery management system and other different components to manage the power and charge the battery and monitor everything, then the size will be increased. So size is one of the important factor when you that you need to consider while using the while you are designing the wearable electronics. So size is one of the factors. Second factor is the efficiency and the power consumption. So if suppose that if you are designing a watch or earpod, if the power consumption is very high for regulating, and there is high dissipation of power with the in form of heat, then it will be, the overall cycle of the battery and overall life of the battery and also the overall efficiency of the whole device will affect. So one first thing that you need to consider while designing a circuit for wearable and choosing the power management as for the wearable electronics or miniature electronics like earbud and the watch is the size. Second thing is the efficiency, and third thing is the option for the harvesting energy. So those devices are very small and they need to be super efficient and super less power consumption consuming. So if you have the IC that is so small, but it will able to manage the battery, it will able to charge the battery, it will able to protect the circuit, it will able to deliver the power requirement by the whole circuit in just a small footprint, and if it will able to do all those work, then it will be great. And if that system if that chip will also able to provide some kind of harvesting system, it will also able to harvest the energy and helps the device to run a little bit longer, then it will also good. So these are the factors that you need to think. One is the size, its form factor, its footprint of the whole IC. Second is the power efficiency. Third is the battery management and the thermal management, voltage regulation. All things should be packed inside the small chip and in a small size, and it will be able to deliver the super efficient power management for the whole circuit. So you have to think about these factors. So there are few companies that I think you can check, and few ICs that I will give you the example of few IC that you might help you in designing the wearable electronics and a smaller electronics or even in other electronics, because these power management ICs are very small. They're super small, and they are packed of a lots of function like over current regulation, over current protection, short circuit protection, battery management system, and all those things. So one is from the Dialog Semiconductor, that is DA9061. Another one is from the Texas Instruments, that is TPSM 8281. This is another IC that size only 1.3 mm to 1.1 mm. It's just a pinch, just a pinch of your fingertip. So they are very super small power management. Another is from Analog Device APD 5300. It's a 1.62 mm. And there another power management IC is from the maximum integrated, that is MAX 7650. That is another super small power management IC. So if you choose those kind of power management that are super small, and that have all those functions like regulating the power supply, protecting the circuit from overcurrent, reverse polarity, or over discharging of the battery, managing the battery in that super small sizes pinch of the fingertip, then it will be great for the wearable device, because you will get extra space for the other components on the circuit, and it will get more space for the battery as well. You can add bigger battery. But if the power management I see itself take a large space of the circuit, then it will be a disaster for your whole design. So you have to think about the size, form factor, and the functionality that is packed inside the small size. And there are few power and management ICs from the Samsung as well, that is SPFPD01. That is another power management IC. So there are we have select a lots of good innovative power management IC that do the energy harvesting, that do the that are very small. Those are the world's smallest power management IC. So you can check the truly innovative section of the electronics for you. Be in the electronics for you magazine, you will get the section of truly innovative, where the electronics for you select the some of the innovative component that helps you in designing the next level of electronics, and that helps you in solving the design problems. So we have selected some of the innovative power management IC that give you the option for energy harvesting, and there are a few power management IC that are the world's smallest power management IC with the package of all lots of function in that small footprint. So you can check that section of the electronics for you and find some of the good power management IC, and few example I've already given you. So for the wearable electronics, you should consider a small footprint, a smallest a smallest ICs, and with the pact of all kind of function without compromising the efficiency and other functions in a small footprint.
Okay, so are there any environmental factors that will affect PMIC?
Yeah, yeah. Environmental factors can significant impact performance, reliability, and longevity of the power management integrated circuits. Here, you can consider first one is temperature. Temperature is a very important factor which environmentally affected on the PMICs. PMICs, so PMICs are designed to operate within a specific temperature range. Exceeding this range can lead to malfunction or reduced efficiency. Another is thermal management. High temperature can accelerate wear and tear of the PMIC components, potentially causing thermal runaway. Effective thermal management, such as heat sink or thermal pads, can mitigate this one. Another is cold temperature. Extremely low temperature can also affect PMIC performance. So there are hill area, then performance of the ICs may reduce. So another is temperature cycling. Frequent change between the high and low temperature can cause the thermal stress, potentially leading to the physical damage of the ICs time to time. Another is humidity. This is also very important. High humidity can lead to condensation, which can cause short circuit, corrosion, and other moisture related damages. Another is corrosion. Over time, moisture can cause corrosion of the metal parts within the PMIC, degrading the performance and the reliability. Another is humidity control. Sealing a conformal coating can protect PMICs from the moisture ingress and associated problems. And third environmental effects are the dust and particulates. Contaminations. Dust and particulates can settle on PMICs, causing electrical shorts or reducing heat dissipation efficiency. Another is environmental sealing. Proper sealing and enclosures can protect PMIC from the dust and particles. Another is some environmental effect is vibration and shock. So in this case, the vibrations and mechanical shocks can cause the physical damage to the PMIC and dislodge components leading to failure. So, to avoid this, we should ensure that the PMIC is securely mounted and pegged in a robust enclosure can mitigate the effect of the mechanical stress. Next one is electromagnetic interference. EMI and radio frequency interference. This environmental effect is also very important. EMI and RFI can affect the operation of the PMIC, leading to erroneous behavior or reduced performance. So, avoid this. Adequate shielding, and proper grounding can protect PMIC from the electromagnetic and radio frequency interference. Another environmental effect is altitude, pressure variations. Changes in atmosphere pressure at different altitude can affect the performance of PMIC, particularly those with the pressure sensitive components. So, avoid these at high altitude. Lower air density can reduce the cooling efficiency of PMICs, necessities enhancing thermal management solution. Another one is chemical exposure is also very important environmental factor. Corrosive environment. Exposure to chemical or corrosive environmental can damage PMICs by degrading the materials or causing the corrosion. Another is so avoid this we have to use a protective coating and material resistant to the specific components to avoid this type of environmental effect. Another environmental effect is radiation. Ionizing radiation in certain environments such as the space application, ionizing radiation can affect PMICs, potentially causing single event upset or long-term degradation. So avoid these. Special design and material can be used to make PMICs more resistant to the radiation effect. Another is airflow and ventilation. Adequate airflow and ventilation are crucial for the dissipating heat generated by the PMICs, ensuring it operates within safe temperature limits. So, properly design of the device, housing, and positioning of the PMIC can optimize the air flow and closure. To mitigate the effects of these environmental effects, several strategies can be applied. First one is robust design, selecting PMIC with wide operating temperature range and environmental rating suitable for the intended application. Another is protective enclosure, using enclosure that protects against the dust, moisture, and the physical damage. Another is thermal management solution, implementing heat sink, thermal pad, and ensuring adequate air. Another is applying protective coating to seal against moisture, chemical, and corrosion. Another is a proper shielding to mitigate the environmental effect. Another is a proper shielding, using electromagnetic and radio frequency shielding to protect against the interference. Regular maintenance, ensuring that the devices are highly maintained to prevent dust buildup and check up for the sign of the environmental damage. So, by considering above these, you can save your PMICs from the environmental effect.
Okay, so is there a need for wireless charging capabilities?
Yeah, now right now the most of the devices where wireless charging and the wireless powering system is trending now, and it's a trending and emerging technology that you can see. And most of the people need this, like in airports you can see the wireless charging capability. In the watch you can, smartwatch you can see the wireless charging capacity. In the smartphones like this you can see the wireless charging capacity. So most of the devices, new gadgets are now not now require the wireless charging capability. So it's better if the power management IC itself have this capability and able to do it by itself. Then it will good because you now need an extra circuit for the wireless charging capability or wireless powering capability. So it will be the good option if your power management IC have this wireless charging and wireless powering capability integrated inside the circuit itself. You need no any external circuits for or external IC for that. And so it is now the required thing for the most of the power management ICs for the wearable like smartwatches and earbuds or smartphones, because most of these devices are now need wireless charging, and it's the need of the people. Most of the people want the wireless charging capability inside the smartphone, inside the earbud, or inside the smartwatches. So for the wireless charging capability in the power management IC, if you are looking for such kind of power management IC that supports these things, so I will list you 3 4 ICs that have capability of that. So one is from the Texas instrument, that is BQ510550P. So this is the power management IC that have the integrated wireless power receiver for the lithium ion charger. So what it will do, if you use this power management IC, it will take the wireless power and charge the battery. It will receive the wireless power, electromagnetic power, and charge the battery. And it also have the capability to detect the foraging object, that is a foraging object detection. So suppose that you put the device on somewhere else, and then it will automatically detect that this thing is not the wireless charger, this is something is, so it will automatically turn off, and it will not transfer or receive the power from that device. So there is another device that is from the analog devices, that is LTC 4120. So this is another IC that you will find that have the wireless charging, wireless power receiver circuit, and wireless battery charger system is integrated inside that IC. And there is another from the Renaissance, that P9221R. This is another IC, that is a single chip IC that use the wireless power receiver inside the PMICs. So these are the few PMICs that have the capability of wireless powering and charging system is integrated inside the PMICs. So it's the need of the time, and it's the need of the thing. And but there are few areas where the wireless charging and wireless power receiving capability is an essential part of the system. Like there are various implantable chips now out there in the market. So if you implant the chips inside the body and it needs to be charged, so you can't put so they have some kind of wireless charging capability. So when you put that thing near the wireless charger, it will able to do the charge. Few implantable electronics are there that have this capability, and they need it. Uh, and there are few areas where you need the wireless charging capability as well, where you not need to, you not need to expose the terminals of the, positive, negative terminals to the outside. Like suppose that you want to use the device uh, with the circuit inside the water. So if you expose that both terminal inside the water, then it might be, some short circuit will happen. So if you enclose the whole circuit inside the, in the waterproof enclosure, and you add the wireless charging capability, then you can put it inside the water, it will work. And whenever you want to charge, you can simply put it on the wireless charger. So none of the terminals are actually exposed outside that cause the short circuit or anything else, and it will help you in the wireless charging. So the wireless charging capability is the need of the time. And I have already told you few IC frames that have the wireless charging capability and wireless power receiving capability. If you want the more list, and if you want us to do more research for you, then you can comment below. You can ask us, and we will go out some of that IC as well in the comment section.
Okay. So, are there any regulatory or compliance issue to consider for PMIC in wearable technology?
Yeah, there are, because they have to pass for the wearable electronics or medical electronics. This is needed. This is the need of the you have to pass the compliance, and you have to pass the various licensing factors and various safety factors, because these power management ICs are responsible for managing the power and thermal management of the whole circuit. Though then these actually need to be passed for certain design. The certification is needed.
Okay. So, this will be my last question. So, how do PMICs contribute to energy harvesting in IoT devices?
So there are few PMICs, like I've already told you few from the EPs, and few other companies have are there, that is producing, and that is there in the market, that supports the energy harvesting things. So, the these energy harvesting PMICs, what it will do, it will increase the cycle of the battery and overall efficiency of the battery, and also it will also increase the life and usage time of the whole circuit. So suppose that you have a watch, you have a earbud, and that have a battery and that not have the any energy harvesting thing, then it will only depend on the battery and it will consume the battery more. But if that earbud also have a energy harvesting PMIC, then what it will do, it will try to make a balance between the energy usage, and it will try to harvest the energy from the environment and use the less amount of battery, and more whenever there is a availability of the ambient energy sources, it will harvest the energy and use that energy to feed the circuit and make a balance between the battery energy and the energy from the ambient, and hence your overall type usage type of the battery and the charge cycle of the battery will be increased if the PMI IC have the energy harvesting capability. And now these energy harvesting capabilities based PMIC are trending, and it's most of the IoT devices and wearable devices, smartwatch wearable devices, and the earbuds are using this technology so that they can increase the enhance the overall efficiency of the whole circuit, overall times and the life cycle of the whole battery and whole system. So I will list you out. I will give you list of few PMICs that have this capability, that have this energy harvesting capability integrated inside, that will able to harvest the energy and feed the energy to the circuit along with the battery as a power source, and along with the ambient energy as a power source both. And it will use both of the energy sources to feed the circuit and optimize the overall need of the need of the circuit, power of the circuit, and also optimize the overall usage of the battery. So one is from the Texas Instrument. The IC name is BQ25570. It's the energy harvesting PMIC with the integrated power management for the battery charging system. And it will able to harvest the energy and also charge the battery using the harvested energy, and also power deliver the power to the circuit while harvesting the energy, and it saves the conserves the battery life and battery cycle. Another is from the analog devices, that is ADP, uh, that is ADP 5090. This is another IC that is from the analog devices. It also have the energy harvesting PMIC, and it is especially optimized for the photovoltaic cell, that is the solar cell. So what it will do? It will harvest the energy from the solar cell and able to charge the battery, and also store the energy and manage the energy in the circuit, and also feeds the power to the circuit as well. So it's the another energy harvesting IC. There is another IC from the ST Microtronics, that is SPV1050. So this is another PMIC that have the energy harvesting capability and the battery charger capability integrated inside the IC. So its voltage range is around 75 millivolt to 18 volt, and it is especially designed, and it is good if you add the super capacitor with this IC. So whenever there is a ambient energy is available, it harvests out the energy and charge the super capacitor, and whenever the and optimize the need of the battery power in the circuit by feeding the charge store in the super capacitor. So whenever there is ambient energy, it quickly charge the super capacitor, and then feed the power from the super capacitor to the main circuit while using lesser power from the battery. So it is another good energy harvesting IC from the ST Microtronics. Then there is another energy harvesting IC from the Cypress Semiconductor, that is not Infineon, that is S6AE102A. So this is another PMIC with the energy harvesting capability, and it is especially designed for the thermoelectric and solar cell generators. So if you add the thermoelectric generator with this IC, then what it will do, it will convert the thermal energy into electrical energy and try to store the charge in the battery or either feed to the circuit. And there is another energy harvesting from the linear technology, that is not the analog devices, that is LTC 3106. It is another DC converter as PMIC with the energy harvesting capability. And there is another energy harvesting IC from the maximum integrated, now it's the analog devices that it max 107710. So it's the another PMIC that have the energy harvesting capability, and it can charge the battery with the ambient energy source, and also feed the power to the main circuit. And there is another energy harvesting IC from the EPH, harvesting PMIC from the EPH, that is AEM10940. And we have selected this energy harvesting PMIC in the electronics for you to innovative section. You can check it out. So what it do, it will captures the energy, it will harvest the energy from many of the ambient energy sources and feed it to the battery and the circuit, hence reducing the overall power consumption and overall efficiency of the whole battery and the circuit. And there is another energy harvesting from the EN Ocean, that is ECT310. This is another power management IC with the integrated energy harvesting system. So these are the few examples that I have told you. If you want the whole list of this, then you can ask us. We will answer you in the comment section, or you can also check the electronics for the tool innovative section. We have selected some of the amazing energy harvesting PMIC that are in a smaller footprint and that will give you this capability for your design. So if you use this kind of latest power management IC that will able to harvest the energy, and that will help you in enhancing the overall usage of the device and cycle of the battery that is used in the device.
Okay, so thank you for your time. We hope this discussion was helpful for you all. If you have any question regarding this topic, do write a question in the comment section. We will get back to you in the next episode. Thank you.
Okay, thank you.